right, so let's assume Mr. Adams does his homework. I do a bunch of math. I know that theta is equal to S over R. So I just go, oh, that's easy. That's 0.3 over 0.9. Well, that reduces down to 1/3. I plug that in, and it says that I have the wrong answer. It's wrong, right? So then I got to go, well, why is it wrong? And then I after looking, I see this. And I realize, oh, it has to be the same units. But let's assume I don't know that. Well, then I go back to the examples. So I go back to the examples that look like that. So I look at example 1, and I notice that in my notes, I canceled out the yards. I reread example 1 in my notes, which only takes, watch, I'll read it for you. It says, find the measure in radians of the central angle theta that intercepts the arc of length 3 yards on the circle with a radius of 6 yards. And so then I wrote down S equals 3 yards, R equals 6 yards. Theta in radians is equal to S over R. Theta is equal to 3 over 6. And then I wrote the yards down, and the yards canceled, so I got 1/2 radians. And I go, well, wait, I think I did that. Let me look at the next example. On the very next example, the second example we did in class, I underlined that the arc length was 3 yards and the radius was 6 feet. And then I noticed right here that I took my 3 yards and converted it to feet, which is 9 feet. Okay? So then you just look at that example. By the way, you're not wasting your time by looking at examples because you're kind of learning, right? That's why we take the notes. So by reading those 2 examples, I might stumble across, obviously, if you don't find out where it's at, but if you read those 2 examples, which only took me like a minute, it might put you in the right space, okay? I don't mind answering questions, but really when you read those examples, it's like you're studying for the test. It helps. Remember, we got to get this in your brain 27 times. So by reading those 2 examples, they went in your brain 2 more times. So then I realized, okay, wait, I got to do this problem over, but they have to be the same units. So I have to convert 9.9 centimeters to millimeters. So I know that 1 centimeter contains 10 millimeters, right? Is that right? I wrote this conversion ratio this way because the centimeters will cancel. 0.9 times 10 is actually just 9. And then I'm left with the units millimeters. Technically, this is a 1. 1 times 1 here. So I got 9 over 1. And then 0.9 times 10 is 9. And then I just have the millimeters here. So now I know that my radius is equal to 9 millimeters. So then I just plug it in now, and I get 0.3 millimeters over 9 millimeters. Now, the interesting thing about reducing this fraction is I know that they're both can be reduced by 3, but I'd really feel comfortable with integer values. So what I'm going to do is I'm going to say to myself in my head, 0.3 over 9, I'm going to divide by 0.3 and then divide by 0.3. 0.3 divided by 0.3 is 1, and then 9 divided by 0.3 we could just do on our fancy calculator. So if I go and I say 9 divided by 0.3, I get 30. So my answer is 1/30 radians.